Okay, let's see how you did. So, example number 2. We have the toy coming off, it's landing in here in the box, it's this far away and that far below, and we want to know what must be the velocity of the toy as it leaves the conveyor belt. Well, that velocity is going to be all in the x direction, right? So essentially what this is saying, what we're looking for is the velocity initial in the x direction. That's what we want to know. Okay. So now that we've drawn a picture and established our origin, let's make our lists of knowns and unknowns. So x initial, x final, velocity initial in the x, velocity final in the x, acceleration in the x, and then time final. And we're going to have the same list for the y. Now, you need to start becoming comfortable with this list, that you'll be able to write it yourself, okay? So that you'll know this right off the bat, that these are the components that we're looking for. Okay, now, if this is my origin, this is where I'm starting, my initial position in the x is at the origin. My final position in the x is 0.4 meters away. My initial velocity in the x, that's what I'm looking for. I don't know what my, I do know what my final velocity will be because the acceleration in the x is 0 meters per second squared. I know that it's going to be the same as that initial. I don't know what that number is, but I know that they will be the same. Y initial, I'm starting at a height of 0.6 away from my origin. I'm ending at the origin as far as the y direction goes. My initial velocity in the y is 0. It's all in the x. Velocity final in the y, we don't know what that is. The acceleration is the acceleration due to gravity. And we don't know the time component. Okay? So we want to know x initial. We don't have enough information here to solve for that. So you better find time using the y components first. So here's my work for the y direction. We're solving for time. I'm going to choose an equation that does not have velocity final, and the only one that is the case is the y final equals y initial plus velocity initial in the y multiplied by t final plus 1/2 acceleration t final squared. Okay. Our final is 0. And our initial velocity is 0. And so we have 0 is equal to positive, because we haven't moved that over yet, y initial plus 1/2 acceleration t final squared. I'm going to add that to the other side, so I'll have a negative y initial is equal to 1/2 acceleration t final squared, and I'm solving for time. So I'm going to rearrange this equation to solve for time. So I'm going to divide by 1/2 and acceleration, and that would equal t final squared, and so I'm going to take the square root of both sides there. Okay, so that should look familiar. So when I plug in those numbers, right now, y initial is 0.6, so negative 0.6 divided by 0.5 times by a negative 9.81. Okay, so we have a time of 0.35 seconds. Okay. And now what we want to do is we want to solve for velocity initial in the x. Okay. So here's my work for the x direction. Again, I think I'm going to use the same equation because, let me think. I want to know the initial velocity. Okay, so I want to know what the initial velocity is. I can't use either of those. Yes, if I use that same equation, then the acceleration is 0, so this whole component will drop out. So that actually becomes a relatively simple equation. So let me show you what I mean. That big equation is x final is equal to x initial plus velocity initial in the x multiplied by time final, sorry, not squared, plus 1/2 acceleration time final squared. Okay, now the acceleration in the x direction, that's 0. And x initial is 0. So that would mean x final is equal to velocity initial in the x multiplied by time final. And I'm solving for that initial velocity, so I'll divide by time. So x final divided by time final will equal velocity initial in the x direction. So I'll plug in those numbers. X final is 0.4 divided by time final, which is 0.35. And so that gives me an initial velocity of 1.1 meters per second. Now we're going to skip example number 3, and let's keep going. Let's go on to number 4. Okay, this is the last one that we're going to do together in the lab. Okay, so in her physics lab, Melanie rolls a 10-gram marble down a ramp and off the table with a horizontal velocity of 1.2 meters per second. The marble falls into a cup placed 0.51 meters from the table's edge. How high is the table? Draw a picture, establish an origin, list your knowns and your unknowns. So we have, here's our table. Here was the ramp that it started on. Okay. Then the marble was up the ramp and it rolled down the ramp. And when it leaves off the table, the initial velocity is all in the x direction. And eventually, through parabolic motion, it's going to hit the ground. Okay? So we know that it has a horizontal velocity. So this velocity initial, that's all in the x direction, of 1.2 meters per second. The marble falls into a cup placed 0.51 meters from the table's edge. So it falls into this cup, and that distance is 0.51 meters. Okay, let's call the base of the table and the floor our origin, our 0, 0 point. Okay, let's see where we at time-wise. Okay, so x components and y components. Maybe we'll try down here. X initial, x final, velocity initial in the x, velocity final in the x, acceleration in the x, and time final. And then y initial, y final, velocity initial in the y, velocity final in the y, acceleration in the y, and time final. Okay. Now, how much of this do we know from our image here? X initial, this is my origin. As far as the x direction goes, I'm starting at the origin, so that'll be 0. X final is 0.51 meters away from the origin. My initial velocity is all in the x direction, 1.2 meters per second. My final velocity is going to be the same, because in the x direction, the acceleration is 0. We don't know the time final. Y initial, that's what I'm solving for, right? How high is the table? Right? We're looking for that height. And so my initial would be the height. Final would be the ground, which we're calling the origin. It's the initial velocity is all in the x direction, so my initial velocity in the y would be 0. My final velocity, I don't know. The acceleration is due to gravity. And we don't know the time component. Okay. Now there isn't an equation to solve for y initial without having both of these. We need at least one of them. And we can solve for the time using the x component here. So in the x direction, I'm going to solve for time so I can take it over to the y. Okay? I could use any equation other than those two because the acceleration is 0, as long as it contained time. Have that. Okay. So basically what I'm saying is I can't use these two because the acceleration is 0. We could use this one or this one. Doesn't matter. We're going to rearrange to solve for time. Now I'll tell you this one becomes really simple because the acceleration in the x direction is 0 and the initial is 0. Let me show you what I mean. So x final equals x initial, velocity initial in the x direction, t final, plus 1/2 acceleration in the x, t final squared. Okay? Now, our x initial is 0. Our acceleration in the x is 0. So if I rearrange this, x final is equal to velocity initial in the x multiplied by time final. And we're solving for the time. So x final divided by velocity initial in the x will tell us the time. So x final 0.51 divided by velocity initial 1.2 gives us a time final of 0.43. Okay. And now we'll use that in the y components here. So in the y direction, we're solving for y initial. I need to pick an equation that does not have velocity final because we don't know that. And the only equation that doesn't have that is y final equals y initial plus velocity initial in the y multiplied by time final, 1/2 acceleration in the y, time final squared. Okay. Now, y final is 0, and velocity initial is 0. So 0 is equal to y initial plus 1/2 acceleration, t final squared. And we're looking for y initial. So let's get that by itself. Let's subtract it to the other side. So negative y initial is equal to 1/2 acceleration, t final squared. And then we can divide by a -1, or this we can multiply by a -1. I guess there's another way we could look at that, and do that to both sides of the equation. So what we end up with is y initial is equal to the negative of the 1/2 acceleration, t final squared. Okay. So I'll plug in those numbers. This is a negative, it'll cancel with that negative. So I'll have 0.5 times by -9.81 times by 0.43 squared. Okay. Now that I have this, it's a it was a negative 0.906. But that's what's inside, and so then we have the negative, so the two negatives cancel. Let me see, I'm working with 2 sig figs, so 0.91 meters. Okay. Okay. Oops. All right. So now, this one, last one, is for you to give a go. Okay? Email me if you have any questions, and it may take a couple of times watching the videos over and pausing and working on it and making sure you're feeling confident with each step as we go on to the next. Okay guys, good work today.